Okay, now we are going to prove proof number 3 of 3 of proportionality theorem. Okay, so you are given the triangle ABC and the line DE parallel to the line BC. Okay, you are given triangle ABC, line DE parallel to the line BC. Okay, you are required to prove that DB over AB is equal to EC over AC. Okay, DB over AB is equal to EC over AC. Okay, solution. So you are going to start with the construction. Okay, construction. You are going to join the vertex B to E and vertex C to D to form the lines BE and CD. Okay, BE and CD. You are going to draw EM perpendicular to AB and DN perpendicular to AC. Okay, EM perpendicular to AB. Okay, and DN perpendicular to AC. Okay, now proving. Now we are going to prove after constructing. So you are going to need DB. Okay, let me show you. You are going to need DB over AB. AB. So you are going to need triangle DBE because you can have DB over. You are going to need triangle ABE because you can have AB. Okay, AB. So you have the area of triangle DBE over the area of triangle ABE. Okay, this is equal to the area of triangle DBE. You have half times base, which is DB, times height, which is EM. Okay, if you extend DB like this, okay, like this, can you see? If you extend DB like this, you are going to have EM is perpendicular to DB. Okay, EM is perpendicular to DB. So EM is the height. Okay, the height is always perpendicular to the base. Okay, for this formula to hold, the base is always perpendicular to the height. Okay, DB is perpendicular to EM. Okay, now over the area of triangle ABE, you have half times base. The base is AB. Okay, triangle ABE, the base is AB times the height. The height is EM because EM is perpendicular to AB always. Okay, AB is perpendicular to EM. Okay, so this is equal to, you cancel a half and a half, you cancel EM and EM. Now you have DB over AB. Okay, we are done on this side. Now on this side, you are going to have EC over AC. Okay, EC over AC. Okay, you have EC, okay, EC over AC. So you are going to use the area of triangle ECD, okay, the area of triangle ECD over the area of triangle ACD. Okay, so area of triangle ECD, okay, over area of triangle ACD, okay, area of triangle ACD. So this is equal to the area of triangle ECD is equal to a half times base, which is EC, the base is EC, times the height is DN, okay, because DN is perpendicular to EC. If you extend EC, okay, if you extend EC like this, can you see? You are going to have DN perpendicular to EC. So this is the height and this is the base for this triangle. Okay, always the base is perpendicular to the height. Okay, so this is over the area of triangle ACD. You have a half times the base, okay, ACD. The base is AC, the height is DN, okay, times DN, okay, the height is DN because DN is perpendicular to AC, okay, the height is always perpendicular to the base. Okay, so this is equal to a half and a half, you cancel, DN and DN you cancel. Now you are going to have this. Okay, so now you are going to use the bottom triangles. You are going to use their areas. Okay, the area of the triangle DBE is equal to the area of the triangle ECD because you have a common base DE. The two triangles have a common base DE and the height is the same. Okay, for this triangle DBE, if you extend DE, you're going to have, this is the height for this triangle ECD. If you extend the base, you are going to have this line perpendicular to this line. So this is the height. Now you can see this height is equal to this height. Okay, this height is equal to this height and you have a common base. So you understand, when two triangles have the same base and the same height, their areas are going to be equal. Okay, so the area of this triangle is equal to the area of this triangle. The reason is, always write the reason, because you have a common base, okay, a common base DE, and you have the same height between DE parallel to BC, between DE parallel to BC, okay, the same height. Okay, so this area is equal to this area because of this reason. Now is this ratio equal to this ratio? If this is equal to this, automatically this is going to be equal to this. Okay, so we are going to check this and this. Can you see? Let me show you. This is already proven. Okay, is already proven. The numerator is already proven. Now you need to check the denominator. Okay, the numerator is already proven. Now you need to check the denominator. Okay, so for the denominator, you have area of triangle ABE. Okay, triangle ABE and area of triangle ACD. Okay, ACD. You have to notice the two areas. Okay, this area and this area, they have a common area, which is area of triangle ADE is common in both areas. You can conclude this. Okay, the denominator, this denominator is equal to this denominator because you have common area. Okay, common area of triangle ADE, and the bottom part, the bottom areas are also equal. This is proven. You can see the bottom part are also equal. The bottom areas, they are also equal. This is proven. These bottom areas, they are equal. Okay, this is proven. Okay, so you can conclude this. Okay, this is equal to this. So the reason you are going to say this area is equal to this area, this is proven. Okay, this area is equal to this area, this is proven, and this area is equal to this area. Okay, this area is equal to this area, this is already proven. So the reason you are going to say this area is equal to this area. Okay, this is proven, and this area is equal to this area. Okay, this area is equal to this area, this is proven. Okay, so therefore now you can conclude this. Okay, this is equal to this, equal to this. Okay, this is equal to this. So we have proved. Okay, this is proof number 3 of 3. Okay, let me erase. Okay,